Okay, let's just dive right into this explainer. Today, we are going to completely dismantle a massive industry myth about AI safety. Look, right now there is this huge push toward using multi-agent large language models, right? And everybody's making these wild assumptions about how safe and reliable they really are. But we're going to pull back the curtain, look at the actual structural realities of these systems, and uncover why true safety evaluation, at least the way the tech industry is currently defining it, is, well, fundamentally impossible.
I mean, think about it. AI agents are increasingly handling super complex tasks for us. They're acting autonomously, they're literally making decisions on our behalf. But this raises a really provocative question for anyone relying on these tools. Can we actually trust their safety guardrails right now? Are the systems evaluating them actually capable of guaranteeing that an outcome isn't going to cause harm?
To answer that, we're going to break this down into 5 key areas. First up, the illusion of safety. Then we'll look at the moving target, explore a concept called no standard for me, contrast preference versus reference, and finally, lay out the actual roadmap to true bespoke AI.
All right, let's start with Section 1, the illusion of safety.
Here is the harsh truth. Adding more AI agents or building these supposedly more sophisticated safety evaluators doesn't actually solve the core safety problem. It just doesn't. Current LLMs are undeniably great at probabilistically evaluating general safety, like they know not to give you a recipe for a crime. But, and this is absolutely crucial, they fundamentally cannot guarantee that an outcome is safe and beneficial for a specific user in a specific, nuanced situation. We are totally confusing a statistical likelihood of general safety with an absolute guarantee of specific safety.
And to understand exactly why that statistical approach completely fails, we move to Section 2, the moving target.
This introduces our first fundamental limit, output instability. Now, LLMs aren't unstable with everything. Give them a heavily structured, math-based problem, and they're highly consistent. But qualitative judgments, where there's no single, fixed mathematical answer, that is like a moving target that literally morphs with every single shot. You can give an LLM the exact same input, and it might interpret the nuance entirely differently. Sometimes it even arrives at completely contradictory judgments on repeat executions. It's almost like the AI is gaslighting itself.
Which brings up a massive prerequisite problem. If the AI interprets the exact same situation differently every time you run it, what exactly are we even evaluating? I mean, safety evaluation inherently assumes you have a stable target to evaluate. If that target keeps shifting, simply running the prompt again or asking a second AI agent to double-check it doesn't somehow establish the absolute truth. Sure, you might get a different answer, but without an independent baseline, more answers do not equal more reliability.
So, what you get is this catastrophic chain reaction. Output instability inherently makes the evaluation target unstable. And if the target itself is unstable, you literally cannot have a reliable safety check on something that won't even stand still.
Okay, but let's say we miraculously fixed output instability. We still hit a second, even larger brick wall in Section 3. No standard for me. You see, safety is not this universally absolute concept. General safety relies on broad, sweeping rules. But what actually constitutes a benefit, a damage, or a danger shifts dramatically depending on who you are, what your context is, and what you're trying to do. Think about it. A financial output that is highly beneficial to an aggressive, risk-taking day trader, that could be a massive, completely unacceptable danger to a retiree living on a fixed income. The exact same output is simultaneously a benefit and a danger, depending entirely on the user.
Current LLMs are packed to the brim with generalized training data. They score incredibly high on general safety knowledge, but they inherently lack what we call a user-specific evaluation reference. They simply do not possess the authoritative baseline required to judge if a specific situation is safe or harmful for you. They only know what is generally considered safe based on the average of all their training data. Which leads us perfectly into Section 4, preference versus reference, where we really need to expose a super common misunderstanding about personalization.
There is a critical, fundamental difference between standard personalization and true AI safety. We have to sharply contrast a simple preference against a reference. A preference is basically like giving a Netflix show a thumbs down. You're just telling the AI, I don't really like this answer. But a user correction to a reference, that's a whole different ballgame. That is a structural, semantic correction where you tell the AI, hey, this situation you just classified as perfectly fine is actually a danger to me. Current LLM personalization only handles those lightweight preferences, not the deep semantic remapping you actually need for true safety.
And because of that, we really have to dismantle the numbers fallacy here. Just throwing a massive crowd of multi-agents at a problem does not magically spawn a single absolute truth. Increasing the number of guessing agents does not miraculously generate that missing user-specific evaluation reference. If one LLM makes an unstable judgment, having a second LLM evaluate it doesn't automatically make the second judgment the undisputed truth.
Now, don't get me wrong, having multiple LLMs cross-verify each other is a fantastic research tool. But let's be super clear about what it actually means. If multiple agents give you the exact same result, that's really just evidence that they share similar past training data. It is absolutely not a bulletproof safety guarantee. On the flip side, if the results are widely dispersed, that's a great signal that you're dealing with an unknown situation. But again, it does not mean the system can perfectly detect dangerous black swan events. So you'll hear researchers out there saying, oh, we just need to build a stability module, or we'll just add dynamic user references. Listen, renaming the problem is not a solution. Claiming you can fix this without concrete mechanisms and independent verification methods is literally just restating the required conditions. It's assuming it's possible, rather than offering an actual, functioning technological fix.
So how do we actually build the upgraded machinery to solve all this? That brings us to our final roadmap in Section 5. True Bespoke AI.
Look, we can't just slap together better evaluators. We have to follow a really strict structural path. Step 1. The system needs incredibly robust unknown detection for when those agent outputs inevitably disperse. Step 2. It requires continual learning that actually moves beyond static pre-training. But the real magic happens in Step 3. Deep user semantic correction. This is where you, the user, get to redefine what danger actually means in your specific context. Only by layering these exact mechanisms can we finally arrive at Step 4, true bespoke AI.
Ultimately, instead of blindly trying to build a better evaluators on top of the exact same flawed foundations, the entire industry has to hit pause and ask, what should AI actually be evaluating? And whose standard of safety are we even using? Because until the focus shifts away from generalized probability and moves directly to your specific semantic reality, true safety in multi-agent systems is going to remain impossible. Definitely something to deeply consider the next time you hand the reins over to an autonomous agent. Thanks so much for joining me on this explainer, and keep questioning the algorithms.